Hey there, grade 5. This is Mr. B, and we are going to be learning about just a bit of a review here. I have to plug my thing in. Classic. You can think it's just like me having to find a marker in class. There we go. So, yeah, we just want to do a review because we're going to have a test at the end of this week. So, this should help us get a little bit prepared. And yeah, it should be fun. Okay, so what are we going to look at first here? First, we just want to think about how do we deal with shapes that are, of different sorts. We have a square, we have an extra circle, maybe an extra triangle, and an extra circle. And what did we say that this guy's shaded, this guy is shaded, and this guy is shaded? Well, what would be some ways we could describe this whole assortment? How many shapes do we have in total? 1, 2, 3, 4, 5, 6. So we have 6 shapes in total. Now, would I write that like this to start and have some other number down here? No, the 6 that we're referring to when we count them all is the total. It's the denominator. Now, I could say how many shapes are there, and there we would say there are 6 shapes, and that's 6 of 6, right? That's all of them. But in our case, we're not going to look at that. So maybe one thing we'd want to do is say how many shaded shapes are there? Well, we can see 1, 2, 3. And so what we do is say 3/6 of the shapes are shaded, right? And we could say the same about the circles, right? 3/6 of the shapes are circles. 2/6 of the shapes are triangles. 1/6 of the shapes are squares, and so on and so forth. And maybe you could find a few more. 3/6 have corners or edges, right? So that could be another thing. But yeah, you get that point, right? The next thing would be to remember is how could we organize these from biggest to smallest, right? Now, when they all have the same denominator like this, what can we do? Well, we just look at the numerator. Which one has the smallest numerator? That's only one part of the 6. So that one is probably going to be our smallest, especially if we are ordering them from smallest to largest. Now we'd start with that one. If we were ordering from largest, well, we just kind of have 3 of 3. So not the most exciting shape. Maybe I should add in another... no, we won't do that. Anyways, you get the point. 2/6, right, is the next one, and then bigger than that is 3/6, and then the rest are all just kind of equal, right? There's no bigger or smaller, which you won't have on the test, obviously. So yeah, that's kind of ordering them, right? So you just have to make sure you know which order. Now, with a that's from yesterday. Don't want that there. Apples, nope. Okay, so yeah, just the one other thing to remember, right? If the denominators are different, right? 1/3 versus or 1/2 versus 1/3, we can kind of remember that the smaller the denominator is, the larger each individual piece is of the whole, right? You chop a pizza in half, or you chop a pizza in thirds. Each third is going to be smaller than 1/2 because you've chopped the pizza into more bits, right? Each quarter is going to be smaller than a half. Eighths, right? Each eighth is going to be smaller. And as you chop it up into more and more little pieces, right, the pieces get smaller. You have more pieces and they get smaller. So if you have the same numerators, the numerator is equal. And in this case, the denominator over here is bigger. We're going to know that this one is in fact larger, right? Or this whole thing is going to be larger. That got really messy. There you go. Okay, perfect. So we don't want to take too much time here, right? So equivalent fractions, right? This is something that was really important that we understood. So when you're going into this test, this is again really important, right? When I say we have 1/2 and I want to find an equivalent fraction that's larger maybe, what do I do? Well, I can just times it by something like 2, right? And what I have to do is I have to make sure I do the same to the top as well, right? And this will give me 2/4. And remember, we can show this like this. You shade in 1/2, right? This is 1/2 of the shape. And it is the same thing as having 2/4, right? It's the same thing, same amount of shaded, just it's broken into more pieces, right? You're not talking about anything different. And you can get this one into a bigger fraction, right? You could times this by 3, and this would 2 times 3 is 6, 4 times 3 is 12, and you see this is still half of the shape, right? So I hope you kind of understand that in equivalent fractions. It's very important for comparing fractions, right? So if I'm asking you if 5 sevenths is bigger than 3/4, we have to do some comparison. It's hard to tell just by looking at these. What we can do here is try and get these to match up. So where does 7 and 4 meet? Well, you just times 4 by 7, which is going to be, if anyone's good, is going to be 28, right? And 3 times 7 as well, we need to do the same thing, is going to be 21. And over here, what we're going to do is times it by 4 instead to get this one to be 28, and then 5 times 4 is 20, right? And there you have equivalent fractions. So now you're comparing 28ths to 28ths, right? And now you can see which one is bigger, and it is in fact this one, right? Just one piece bigger. So yeah, that's a very important part in figuring things out. Last one other thing we have to remember is that with fractions, you always need equal parts. So if you see a fraction that doesn't have, or a shape that's divided improperly, maybe it's divided something and there's a tiny piece, you would know that it's not a proper fraction. So that'll help you on the test to keep that in mind. Okay, the final thing is just converting between mixed and improper numbers. So a mixed number, right, is like 1.5. And an improper number would be like 23/7, right? And the way we convert, sometimes we want to convert this into an improper fraction. So what we do, right, is we say we have one whole, we times the 1 by the 2, right, because each one piece, right, basically we have 1 whole and a half here, that's what we're saying. And we're just chopping this into 2 pieces to make it halves, right? So we times it by 2 to see how many halves we have, and that would be equal to 2, and then we just add the, so it's 2/2, and we add the 1/2, and so we end up with 3 halves, right? You see 1, 2, 3. And to go the other way, we go, let's do one more, 2 and 5/6. Okay, so what do? We have 2 wholes. That means that each whole that we have is going to be split up into 6 parts. Right? We have two whole pizzas and one pizza that is not whole. We have most of the pizza but not the whole thing. And so what we're going to do is we're going to take this pizza and we're going to split it into 3 bits, right? Each 6 bits, and this one will also be 6 bits. So it'll be 6, 6, and 5/6, right? This one will have the same thing going on here. And so what we're doing really is 2 times 6, which is equal to 12, right? And it's 12/6 plus 5/6, and that's going to give us 17/6, right? So that's fairly easy. Now this one, when we're converting the other way, we can go like this. We just take the 23 and we want to see how many wholes this can make. And what we can do is just divide. So 7, or 23 divided by 7, how many times can 7 go in? It can go in 3 times, right? And that'll be 21 minus, and so you see why division and multiplication is really good, because if you can figure this out quickly, it's going to save you time throughout all the math that we do in the future. So this will give you 2, and so we're left with a remainder of 2, and so we know that we have 3 and 2/7 left. And voila, there you go. Now we could convert this one too, just to prove that it works, right? 17 divided by 6. How many times can this go in? Well, it can go in twice, right? Because that'll make us 12 minus that. This will leave you with 5, remainder 5. And so what you're talking about here are sixths. So it's 5 remaining sixths. So you have 2 wholes, right? 2 wholes, and 5 remaining parts, which are sixths, and you get your number back again. Okay guys, that's the main thing that we need to figure out today. So remember, when you're going from mixed number to improper, you're multiplying. When you're going from an improper fraction to a mixed number, you are dividing. I hope this helped. Tomorrow we'll have a little bit of a review in our actual lesson or Zoom meeting. So hope that is useful for you guys. Cheers. Bye.